Now let us learn how to approach chapter 9, which is some applications of trigonometry. There are some prerequisite things that we need to know before we get into this chapter. Number one is the trigonometric values for 30 degree, 45 degree, and 60 degree. What are all the values for sine theta, cos theta, tan theta? For that matter, other trigonometric ratios also. But the most important thing in this chapter will be tan theta. Most of the problems are dealing around tan theta. So we should know tan 30 degrees 1 by root 3, tan 45 degrees 1, and tan 60 degrees root 3. So this is something that we should know for sure. With this idea, we are getting into this chapter. About this chapter, a very, very important thing in this chapter is we need to know how to draw the diagram from the given question. So the chapter is basically based on statement problems. We have to understand and comprehend the statement problems, and we have to convert them into diagrams, and from which we'll be able to understand what we need to find. So what I mean by that, there are certain basic things that you need to understand about diagrams in this chapter. First thing is, they would have given something called as point of observation. So we can take it as P or A or whatever. So from the point of observation, whatever you can draw as a straight line like this, that is called as the horizontal. So this is called as the horizontal line. Now, imagine a person is standing at the point P and the person is sighting a bird. Okay, a bird is flying like this. And whichever line that connects this P to the bird's point, that line is called as the line of sight. So now the angle formed between this line of sight and the horizontal is what we call it as angle of elevation. So this is something that we need to know. I repeat, let us assume the observer is at the point P and the observer is spotting a bird in the sky. Now, the straight line vision of the observer is called the horizontal. That is, the observer is not turning his head up or down. Instead, he's looking at a straight line of vision. Then that straight line of vision is called as horizontal. So the person, when he's trying to sight a bird, then he raises his head to look at the bird. So to which angle does he raise his vision, or to which angle does he raise his head? That angle is called as the angle of elevation. And the imaginary line that is drawn from the observer's eye to the bird, that imaginary line is called as line of sight. Similarly, let us imagine now that the observer is standing on top of a lighthouse. So the point P will be here. So the observer is at the top of a lighthouse, and the observer is trying to look at a boat or a ship that is traveling in the sea. Something like this. Now here also, the straight line from the observer's eye, that is called as the line of sight. Sorry, that is called as the horizontal. And so the observer would have to lower his head or his vision to look at the boat, and that line is called as the line of sight. And the angle that is formed between the horizontal and the line of sight is known as the angle of depression. So this angle is known as the angle of depression. So this is something that we need to know before entering into this chapter. So when you lower your head and when you look at something that is below you, from your straight line of vision, that is called as angle of depression. And when you raise your head and you look up to something in the sky or something that is like little above you, then it is called as angle of elevation. So these two concepts we need to understand before we get into this chapter. With this idea, let us try to approach question number 1. For first question, they have given the diagram. But if you look at the rest of the questions in this exercise, most of the questions, they would not have given the diagram. So we have to practice the diagram. Let's see how that is. So even though in this question, they have given the diagram, let us try to understand how to get the diagram from the question. So if you look at the question, a circus artist is climbing a 20-meter long rope. So we know that there is a circus artist who is going to climb a 20-meter rope, but we don't know whether the rope is vertical, like completely straight, or the rope is at an angle, for which we have to proceed with reading the question. So they have given the circus artist is climbing a 20-meter long rope. which is means the rope is tightly stretched and tied from the top of a vertical pole to the ground. So this is the vertical pole. So vertical means it's completely straight. So as you all can see, this is the vertical pole. AB is the vertical pole, and the rope is nothing but AC, which is tied from the top of the pole to the ground. So this is what they are trying to say. I repeat, there is a 20-meter long rope which the circus artist is about to climb. But the dimension of the rope, in the sense where the rope is, whether it is completely horizontal or vertical or at an angle, we don't know. For that only they have given this line, which is tightly stretched and tied from the top of a vertical tower. So the rope is tied from the top of the tower to the ground. So this is the vertical tower. Vertical means it's always straight. So AB is the vertical tower. Let me write it for you. So we understand that AB is the tower and AC is the rope. Okay. So it is basically like this, that there is a rope here. From the top of the tower, the rope is tied to C. It is tied to the point C. Okay. Point C is in the ground. Okay. And we are asked to find the height of the pole. So height of the pole in the sense, so this should not be tower. This is basically a pole. Okay. And this is the rope. So we are supposed to find the height of the pole. So this is what we are supposed to find. So I'm representing it as a question mark so that we understand what needs to be found. So this is what it is. They have also given one more thing. If the angle made by the rope, we know that this is the rope with the ground level. This is the ground. The angle made is also given as 30 degrees. So we have all these data given in the question. With this approach, we are going to find the answer. So now let us assume the pole's height to be h, and that is what we need to find. Okay, we are supposed to find the pole's height. For 30 degree, what we have to find is the opposite side, and what is given is the hypotenuse. Because there is only one angle that is given, 30 degree. And for 30 degree, what we have to find is the opposite. And this 20 meter that has been given is the hypotenuse. So opposite by hypotenuse is sine. So we apply sine 30 degree. So this choice should be made very cautiously. Whether you're going to apply sine or cos or tan depends on the question and what you have been asked to find. So sine 30 degree, opposite is AB. Angle side opposite to 30 degrees AB, and hypotenuse is AC, which is nothing but, we know the value of sine 30 is 1/2. So AB is nothing but AB is what we have to find out, which is h, and AC is 20. So is equal to 1/2. Now the 20 goes to the right side and it becomes 20/2. So you get the answer as 10 meters. So this is how we do the first question. With respect to the second question, a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. Now let us break this question into two parts. Let us try to understand till here first what they are trying to say. So let us imagine there is a tree, something like this. Okay, there is a tree. And the tree is breaking due to storm, but the tree is not getting completely uprooted. What I mean by that is the tree is not broken from the bottom. So somewhere at the top it is broken, like something like this. It's broken like this. Okay, so this is how it is. So the tree is falling down. So initially the tree was like this, but after breaking, the part that has been broken is falling down. And the top of the tree in the sense this top. Okay, so this is making an angle of 30 degrees with the ground. So this is the question. I repeat, a tree is breaking and the broken part is falling down, as you all can see, and it makes an angle of 30 degrees with the ground. When it falls down, it makes an angle of 30 degrees with the ground. So the diagram that I'm going to draw now is something like this. I will be writing a few tags for you to understand. So here, first thing that we have to understand is this is the unbroken part. Okay. And then this is the broken part. And this is the ground. Now, actually, this is like this. So basically, I would say this is something like this. This is the tree. This is also the trunk. And this is the topmost part of the tree that is making an angle with the ground. And they very clearly given that the angle that the top of the tree makes with the ground is 30 degree. So this is something like 30 degree. And we name this triangle as ABC. So AB is the broken part, BC is the unbroken part. Okay, so it's not broken. Okay, so now this angle is 90 degree. Okay, so now what we have to understand here is what are they trying to ask? So the third line they have given the distance between the foot of the tree. What do they mean by foot of the tree is this one. C. C is the base of the tree. And look at this line, the second part of the question, the distance between the foot of the tree. That is the distance between C and to the point where the top touches the ground. So where did the top touch the ground? It is at A. So the top touched the ground at A. The top of the tree touched the ground at A. So the distance between these two is given as 8 meters in the question. That is the second part of the question. So instead of giving AC equal to 8, they have given it as a statement. So we understand that this is 8 meters. So this is what is being given in the question. The value of AC is 8 meters is what is given in the question. So instead of giving it as AC equal to 8, they have given the distance between the foot of the tree. Foot of the tree is C to the point where the top touches the ground. Wherever the top is touching the ground, that is A. And this distance is 8 meters is what they have given. So this is very, very important. So they have asked us to find the height of the tree. So what do they mean by height of the tree? Is basically the total height of the tree, which is AB plus BC. That is the broken part plus the unbroken part also. So we have to add both of them. When they ask us to find the height of the tree, they're not asking us to find the height of the non-broken part. We are supposed to find fully how the tree was initially before breaking. The total height of the tree means we have to find AB, that is the broken part, BC, that is the unbroken part, and we have to add both of them. So we have to find AB and BC, both of them we have to find. So let us do it one by one. So in order to find AB, okay, and the only angle that we have been given is 30 degree. For 30 degree, AB is the hypotenuse. And for 30 degree, the given side, 8 meters, is the adjacent side. So we know that adjacent and hypotenuse, it is nothing but cos theta. So we are going to use cos concept. It's very, very important which trigonometric ratio that you choose. So we are choosing cos 30 degree. I'll tell you why we are choosing cos 30, because the given value 8 meter is adjacent to 30 degree. And the one that we are going to find is hypotenuse to 30 degree. So cos 30 degree is equal to adjacent to 30 degree is AC divided by hypotenuse is AB. And we all know that the value is root 3 by 2. Cos 30 degree value is root 3 by 2. Now AC is 8 that is given in the question, and AB we don't know. That is what we are going to find out. This is equal to root 3 by 2. Here it is very, very important. What we have to do here is AB comes here, 2 comes here, and root 3 also comes to the denominator. So what I mean by that, or I can even show it to you differently. Let us just cross multiply. When you do cross multiply, 2 goes to the left side, becomes 16 equals, we get AB root 3. This is what we get. AB goes to the right side, gets multiplied. Now, this root 3 comes to the denominator. Now, what we are getting is AB is equal to 16 divided by root 3. That is, this root 3 will come to the denominator in the next step. We need only AB, not AB root 3. So we are bringing root 3 to the left side. So it becomes division because it's in multiplication on the right hand side. Now, this is the value of AB. So some of you might be wondering, should I really rationalize the denominator? Of course, yes, but not needed at this point of the solution. We will do it at the end. Next, so we have got the hypotenuse, that is the broken part, which is 16 by root 3, and I'm substituting it in the diagram so that we have an understanding that that has been finished. Now, the only thing that we are left with is the opposite side. We have to find BC also. If you look at this thing, we have to find BC as well. So BC is opposite to this. For 30 degree, BC is opposite. And the given side 8 meters is adjacent. So opposite and adjacent, we know it is tan. So we are applying the concept of tan, which is tan 30 degree is equal to opposite is BC and adjacent is AC. The value of tan 30 is 1 by root 3. We all know that. And BC is what we have to find. AC, we know it is 8, is equal to 1 by root 3. Now, when this 8 goes to the right side, you get BC equals 8 by root 3. So this is what we are getting for the non-broken part. So this is something that we need to understand. Now, having gotten both the values, what we are going to do is we are going to add them to get the total height of the tree. So as you can see, this is the total height of the tree, which is H is equals AB plus BC from whatever we wrote initially. Now the value of AB is 16 divided by root 3 and the value of BC is 8 divided by root 3. Since the denominators are the same, we add the numerators, we get 24 by root 3. But at this point, we should take the conjugate in order to rationalize the denominator. Denominator should not have a root part. So when we do into root 3, we are getting 24 root 3 divided by 3. In the denominator, root 3 and root 3 will become 3. Now this 3 will get cancelled with the 24 8 times. And the final answer is the total height of the tree is 8 root 3 meters. We have to conclude along with the unit because meters is the unit that they have taken. It's preferable for us to write it as a statement. So we conclude by saying the height of the tree is 8 root 3 meters. So we need not substitute the value of root 3. So some of us know that root 3 is 1.73. We need not substitute the value of root 3 and finish the answer. It is enough if we write it like this, unless and until we have provided the value of root 3 in the question. Then you have to substitute, multiply and find it out. That is how we approach the second question. Now let us try to draw the diagram for the third question. Very important thing that we have to understand is it need not always be one triangle. It can also be two triangles. Like in this question, in third question, there is a contractor who plans to install 2 slides. That like the slides in the park. So why he is installing 2 slides is because one for younger children and other one for older children. That is the idea. Now for the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter, which means it is something like this. So let us imagine this is the ladder of the slide. Okay, something like this. And this is the slide. Okay. Now, what has been given in the question is, they have very clearly given that, so this is the slide that we are considering. Okay. So this is the ladder and the younger children will come to the top of the ladder and then they will kind of slide through this. This is how this is. Okay. Now, the height of the slide is 1.5, which means this is 1.5 meters. I mean, the ladder thing, and is inclined at an angle of, look at the line in the bottom. It is inclined at an angle of 30 degrees to the ground. So it is inclined at an angle of 30 degrees to the ground. Inclined means to what extent it is slant. So it is making an angle of 30 degrees with the ground, which is making an angle of 30 degrees. The slide is making an angle of 30 degrees. So this is one slide. And there is another slide for elder children, which is at a height of 3 meters. So this is the ladder. So it is at a height of 3 meters. So for older children means grown-ups. So they will be able to take a little more risk. So this is the slide for older children. Okay. Now what they have given is the height of this slide is 3 meters. It's quite steep. If you look at the line given in the question, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degrees. So this angle is 60 degrees. This angle is 60 degrees. So the angle that it is making with the ground, that is 60 degrees. So these are two diagrams, but the same question. So let us imagine, or let us name this slide as ABC, and let us name this slide as maybe DEF. Now, what has been asked in the question is we are supposed to find the length of the slide in each case. We are supposed to find this length, AC and DF. What is the length of the slide? I mean, when the children are sliding through the slide, what is the length that they will cover? This is what we are going to find in this question. Now, it's very clear that for 30 degrees, the given side 1.5 is opposite. And what we have to find the length of the slide, that is hypotenuse. So we understand that we have to use the trigonometric ratio sine. So we apply sine 30 is equal to opposite is 1.5 and hypotenuse is AC. And the value of sine 30 is 1 by 2. I repeat, for sine 30, the opposite side is 1.5 and hypotenuse is opposite to the right angle, which is AC. We know that sine 30 is 1 by 2. Now 2 goes here and AC comes here. Now this would become AC equals 3 meters. Because AC goes to the right side, 2 comes here. So 1.5 into 2 will become 3. So this is how we get the length of the slide for the smaller children. Now, same thing when we apply here for sine 60, the opposite side is 3 and the hypotenuse df. And we know the value of sine 60 is root 3 by 2. Now what happens? df goes to the right side, 2 comes to the left side. Very similar to the previous problem. We get 6 is equal to df into root 3. Because 2 comes to the left side. Now root 3 comes to the left side, you get df is equal to 6 divided by root 3. But we don't leave the final answer with an irrational denominator. So we rationalize the denominator by multiplying it by root 3 and root 3. So we get 6 root 3 by 3. In the denominator, root 3 into root 3 becomes 3. Now this 3 gets cancelled with the numerator. And we get the value of df as 2 root 3 meters, which is the length of the slide for the older children. So these two are the lengths of the slide that the contractor has made. So this is what the question is all about. Let us understand how to do fourth question. The angle of elevation of top of a tower from a point on the ground. First, let us understand and try to draw the ground. So maybe this is the ground. We'll understand that this is the ground. And also there is a point on the ground. And that point I'm taking it as P. There is a point on the ground and I'm taking it as P. Now, the angle of elevation of a top of a tower. So there is also a tower somewhere here. So I'm drawing the tower. So the tower is something that looks like this. Okay. So I'm just trying to draw a tower. So we have a tower like this. Okay. So this is the tower and that is the point of observation. Now the question is the angle of elevation of the top of the tower. The top of the tower is this point. I mean BC. So C is the bottom of the tower and B is the top of the tower. So we imagine that B is the top of the tower. Now, the angle of elevation of top of tower from the point on the ground. So we have to join both of them. We have to join the point and the top of the tower. So this angle of elevation is given as 30 degrees in the question. So how we have to read the question? The question goes like this. Please look at fourth question. So the angle of elevation of top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. So the angle of elevation is given as 30 degrees. So what is this 30 meters away from the foot of the tower? What are they trying to talk about? So the angle of elevation of top of a tower from a point on the ground, which is, so the point is, okay, the point is 30 meters away from the foot of the tower. We all know C is the foot of the tower and they have given the point is 30 meters away from the foot of the tower. So we mark this PC as 30 meters. So this is also given in the question. And now we are supposed to find the height of the tower, which I am taking it as h. So we have to find the value of h. This h is what we have to find out according to this question. So it's very clear that we have to find the opposite side because the height of the tower is nothing but the opposite side and we have been given with the adjacent side. So then it's very evident from this diagram that we have to apply tan. So we apply tan 30. We can also use cot 30. So when we use tan 30, opposite side is h. That is what we've assumed it as. And the adjacent side is 30. So opposite is h, adjacent is 30. So now tan 30 value is 1 by root 3 and h equals, the 30 goes to the right side, it becomes 30 divided by root 3. Now we can take the conjugate. So you get root 3 by root 3. So this becomes 30 root 3 by 3 and the denominator 3 get cancelled 10 times and you're getting 10 root 3 meters. So this is the height of the tower.